So in the previous video, we talked about the different types of uh, functions: linear, quadratic, cubic, square root, absolute value, and so on. So we want to look at how, given an equation and its parent function, or its parent equation, adding information to the equation, how does it translate? How do we transform that equation? So we're going to look at starting off with the vertical shifts and horizontal shifts. So it says let f be a function and c be a positive real number. And so we have a function here. Let's look at the example. Use the graph of f of x is equal to the absolute value of x to obtain the graph of g of x equals to the absolute value of x minus 3, and h of x is equal to the absolute value of x plus 7. So here you have your parent function. This is your f of x equals to the absolute value of x. Or we can also call this our absolute value equation. We, instead of using f of x, we can use y equals to the absolute value of x. Means the same thing. But what happens when we add a number after the our absolute value? When it's the last term of that equation, or we call it a constant term. Well, this is where what would take place is that the graph is going to shift vertically. So as we look at our first graph, we have here g of x is equal to the absolute value of x minus 3. Well, as we look at the minus 3, this tells you how the graph is going to shift. So our rule says if our constant term of this function, if it's negative, then we're going to shift downward that many units. Okay, if it's positive, then we're going to move up that many units. Now here is the table. I want you to see this. Here's the table for the absolute value equation for the f of x is equal to the absolute value of x. So these are the points, some points that I've identified on the graph. Now, we will decide what takes place whenever, if let's say that you didn't have the graph in front of you, and I ask you, well, what are the points when this we attach a minus 3 to this g of x is equal to the absolute value of x, what happens? Well, we all know that it's going to shift down 3 units or move down 3 units. But what would be the points? So here are the points here that I've identified in that table. And we can count. If we didn't have the ordered pair, we can count and move our graph down that many of spaces. Okay. So we can start at 0, 0, and we count down 3 units. 1, 2, 3. From 1, 1, count down 3 units. 1, 2, 3. From 2, 2, count down 3 units. 1, 2, 3. And we're going to go on the left hand side, negative 1. 1, count down 3 units. 1, 2, 3. We have negative 2, 2, count down 3 units. 1, 2, 3. Okay. So we have a few points. That's all we need. We don't have to look at every point on the parent graph. And let's connect. It's still going to be a V-shaped graph. graph, um, but it just all of the points shifted or moved down 3 units. Now, if we didn't have the graph and I ask you, okay, hey, here's a table and we have the g of x is equal to the absolute value of x minus 3. What I want you to understand is what is moving will be the y coordinate. What you would what you would do here is take this 2, since we are subtracting 3 units down, that means we're moving along the y-axis. So we will our y coordinate would change. Okay, so we would subtract 3 from the 2, which gives us this -1. We will subtract -3 from 1. We have here, what's that, -2. This is -3. Then this gives us what's that, -1, and then this gives us 2. Okay, -2. So if you notice, what's going to change here whenever we have a number after our or the last constant term here, what changes here, either you're going to add or subtract the y coordinate. Okay, that number of units. Meaning we would, since this is -3, we would subtract 3 from the y coordinate. This would be our y coordinate here. So we have here -2, -1. Here we go. We have -1, -2. We have 0, -3. We have 1, -1. And then we have 2, -2. So let's do the next one. We have h of x. This is a given function. Is equal to the absolute value of x plus 7. So what this means here is that for this equation, we're going to move, the graph would move, it would shift up or move up 7 units. So from 0, 0, we count up 7 units. 1, 2, 3, 4, 5, 6, 7. Okay, from 1, 1, starting with our original graph, count up 7 units. 1, 2, 3, 4, 5, 6, 7. 2, 2, count up 7 units. We would go 1, 2, 3, 4, 5, 6, 7. And then to the left, count up 7 units. And then we have enough points to connect so that you can see that this is our absolute value of x plus 7. So when we have a constant number, the last number of that equation, that means there's a vertical shift. Now, let's move to horizontal shift. Okay, it says here, we're going to use the same graph. The f of x is equal to the absolute value of x. To obtain the graph of g of x is equal to the absolute value of x plus 4, and h of x is equal to the absolute value of x minus 5. So we're going to draw 2 graphs here, but this time it's going to shift horizontally. So when there's a number within the grouping symbol, our grouping symbol is the absolute value, it's going to shift. How? Let me show you and let me highlight how it's going to shift. So it says here, When the constant term is positive, okay, here we go. It says when C a positive number, when the constant term here is positive, you're going to move left. So you're going to go in the opposite direction. So we have the g of x equals to the absolute value of x plus 4. When the number is inside the grouping symbol, you move in the opposite direction. So for this example, we're going to move left 4 units. Okay. Now, and then it also was noted that when your constant term is negative, you're going to move to the right that number of units. So here we have our h of x is equal to the absolute value of x minus 5. Okay, so here's our h of x is equal to the absolute value of x minus 5. Because that constant number is negative, we're going to move right 5 units from the original graph. So let's take a look at our g of x is equal to the absolute value of x plus 4. So from 0, 0, we count 4 units to the left. 1, 2, 3, 4. So our new point starts at, we have negative 4, 0. Going back to our original graph, count over, find points and count over. Okay. So here at 1, 1, move over 4 spaces to the left. 1, 2, 3, 4. 2, 2, we move over. 1, 2, 3, 4. And then negative 1, 1, count over 4 units. 1, 2, 3, 4. Then negative 2, 2, count over 4 units to the left. 1, 2, 3, 4. So here's our graph. And then that is our g of x. And then our h of x, I'm going to color that in brown. We have, which is the absolute value of x minus 5. Because it's 5 minus 5, we're moving right 5 units from our original graph. So starting at 0, 0, count over 5 units to the right. 1, 2, 3, 4, 5. And then the other points, let's start at negative 2, 2, count over 5 units. 1, 2, 3, 4, 5. Negative 1, 1, count over 5 units. 1, 2, 3, 4, 5. Then at 1, 1, count over 5 units. We will be at 6, 1. And then at 2, 2, count over 5 units to the right. 1, 2, 3, 4, 5. And then connect. So there we go. And we will definitely be putting all of this together, giving you some equations, and I'm going to be asking you, how does it move? Up, down, left, right? Will it reflect? Will it stretch? Will it shrink? So we'll be looking at all of that.